Solving equations. An equation is a statement that two expressions are equal. It has an expression, an equal symbol, and another expression. The special symbol that it tells us we have an equation is the equals. So if we watch for the equal symbol, we'll know we have an equation. For expressions, we simplify, which means to remove parentheses and combine all like terms. For equations, we solve, which means to find the value, which makes it a true statement. If we stay on one side of the equal sign, we have an expression and we can simplify. We can also do the same on the other side of the equal sign. We will use both sides when we solve. Our goal when solving an equation is to isolate the variable. To help us achieve that goal, we perform the reverse operation on both sides of the equation to get rid of terms. We want to make things cancel out. Let's review our operations. We have addition, subtraction, multiplication, and division. When we solve equations, we want to reverse these operations. So if we have an addition, we can do a subtraction to reverse. If we have a subtraction, we can do an addition to reverse. If we have a multiplication, we should do a division to reverse. And if we have a division, we can do a multiplication to reverse that operation. Let's look at some examples. First, we have x plus 7 equals 12. You want to make sure that you learn the process. Don't just look at that and say the answer. I'm sure that most of you could look at that and say, well, 5 plus 7 would be 12, so the answer is 5. But you want to learn to understand the process. So we will first make sure it's an equation. It needs an equal symbol. Go on the side with the variable, and you're going to take off anything else. So to isolate our x, we want to take off this 7. The 7 is added to the x. So to make it cancel, we're going to subtract a 7. And we will have to do it to both sides. So this is what we had. Our new operation is we're going to take 7 away. So we brought down what we had, and we took 7 away. We brought down what we had, we took 7 away. Now we'll clean up, and this positive 7, negative 7 are going to cancel. Leaves us x equals, simplify on the right-hand side, 5. X is isolated. That was our goal. For our next example, x minus 5 equals negative 3. We want to isolate the x, so we go on that side. That means we want to get rid of this minus 5. To make it cancel, we should add a 5 to both sides. So we'll bring down what we have, and we will add a 5. You should always make sure your equals come straight down. Bring down what we have, and we will add a 5. So we added 5 to both sides. Clean up. X equals. On this side, you have to watch your signs. You have different signs. Subtract, sign of the larger, which will be positive. So we get x equals 2. For our next example, 1 equals y plus 3. This equation is just turned around a little bit. That's okay. We don't care if it looks backwards. You should go on the side with the variable to solve. So we should be on the right-hand side. There's the y. That means we want to take off the 3 so that we can isolate the y. The 3 is added, so we should take it away. So on the left-hand side, we need to take it away. You should write your new piece after. Bring your equals straight down. We'll write what we have on the right-hand side, and then we'll take our 3 away. Clean up. That one cancels. That was our goal, to cancel that piece out. On the left-hand side, watch your signs. These are different signs. Subtract, sign of the larger equals straight down, and keep your y. -2 equals y. Your y is isolated. That was our goal. For our next example, 3x equals 12. Go on the side with the variable, so you're on the side with the x. Notice the operation between the 3 and the x. They are side by side, so they're multiplied. To reverse something that's multiplied, you should do a division. So we're going to divide out the 3. When you divide, the division is the reverse. You always divide by the sign of the coefficient. The 3 will cancel. That leaves us x equals 3 into 12 will go 4 times. X equals 4. X is isolated. That was our goal. Our next example, -5x equals 10. Go on the side with the x. Notice it's right beside the -5. The operation there is a multiplication. To reverse it, you need to do a division, and you need to divide by the coefficient, which is a -5. So divide on both sides by a -5. Clean up. These will cancel. Leaves us a positive 1x equals a 2. You only have one negative sign. That's odd, so negative. X equals -2. Our next example, -x equals 4. This equation is not quite finished. You're not allowed to leave a negative coefficient on the x. So if we think of what our coefficient of the x is, it's actually a -1x. Then we would realize what to do. It's multiplied by the x, so we would need to divide on both sides by a -1. The two negatives would give us a positive x equals, divide, we get 4. We only have one negative. That's odd, so negative. So we have x equals -4. X is isolated. That's our goal. For this problem, go on the side with the x, and if we read it to ourselves, it says x is divided by 5. To reverse a division, we would do a multiplication. So to get this 5 off, we should multiply by 5. We need to do the same thing on the other side. Multiply by 5. And this will cancel. Will leave us x equals a positive 15. Solving formulas is a good way to make sure that we're okay with the process of solving equations. So they have to tell us which variable to solve for. It says we're going to solve for x. That means we want to isolate the x. So we're going to go on the side with x, and we'll take off anything else that's on that side. So x is here. That means we want to take off the y. The y is subtracted. So how should we cancel it? We should add a y to both sides. That will make it cancel. So this is what we had. We're going to add a y, so they will cancel out. We have to do the same thing on the other side. On the left, they will cancel. Leaves us x equals. On the right-hand side, we can't do anything. These are not like terms. But our variable x is isolated. That was our goal because that's the one we were asked to solve for. Let's look at another formula problem. And this one asks us to solve for b. That means we want to isolate the b. We should go on the side with the b, and we'll get rid of anything else that's there. So we want to get rid of the p. Notice the operation between the p and the b is multiplication. So to get the p off, we need to divide by it. Do the same on both sides. On the left-hand side, it will cancel to leave us just b. And these are not alike on the right-hand side. There's nothing you can do. It's okay that it looks like a fraction. b is isolated. That was our goal because they ask us to solve for b. Let's go back to numbers and look at a couple more equations. On the left-hand side, notice we have some like terms. We can simplify those as long as we stay on the left-hand side. So the negative 10x and 11x can go together. That will give us a positive 1x or just x. Bring your equals straight down. If we stay on the right-hand side, we can simplify that expression. 9 minus 5 gives us 4. And now we have just a one-step equation to solve. Go on the side with the x, and you're going to take off the 5. The 5 is added, so we will take it away. Make sure you do it to both sides. Clean up. X equals a negative 1. Different sign, subtract, sign of the larger. Let's look at one more example. This one has some simplifying on each side that we can do. On the left-hand side, the x terms can go together. So we have 4x minus 3x gives us just 1x minus 6. Bring your equals straight down. If we stay on the right-hand side, those numbers can go together. They are different signs. Subtract, sign of the larger, so positive. Now we have a one-step equation to solve. So we'll go on the side with the x, and we're going to take off the 6. It's subtracted, so we should add a 6 to both sides. On the left-hand side, it cancels to leave us x equals 9. X is isolated. That was our goal. Solving two-step equations. When solving equations, we isolate the variable on one side of the equal sign. First, we simplify on the left-hand side by combining any like terms or distributing. We simplify on the right-hand side by combining any like terms or distributing. Then we are ready to start solving. Let's look at this problem. 3x minus 5 equals 7. This problem is already simplified. Notice there are no like terms on the left-hand side. There are no like terms on the right-hand side. So we're ready to start solving. We want to isolate the x. So we should look on the side with the x. We want to get it all by itself. So we're going to need to get rid of the 3, and also we're going to need to get rid of this 5. We have to decide which one to get rid of first. Think of the x as a package. You would like to unwrap the package. On a package, the thing closest to it, like our 3, might be the wrapping paper. Also on a package, you might have a ribbon, which would be a little bit farther away. So the 5 would be like a ribbon. So if we want to open the package, we want to get to the X. First, we should take off the ribbon. So take off something that's on the package, but farthest away. And then last, we'll take off the 3, which would be like the wrapping paper. Another way to think of these equations is you're going to go on this side with the variable. Anything added or subtracted is going to come off first. You want to save the division until last. So let's solve this equation. We're going to start on this side with the x, and we're going to take off the 5. It's subtracted, so to make it cancel, we're going to add. Remember, you do the reverse operation. I usually bring down what I have and then do the new step. Equals come straight down. And you also have to add the 5 over there for it to be okay. Clean up. Now go back on this side with the variable and you're ready to get rid of the 3. It's multiplied, so to get it off you will divide. Remember, when you divide by the sign of the coefficient. The division itself is the reverse. 3's are going to cancel, leave us just x equals a positive 4. Let's look at this equation. Negative 2y plus 5 equals negative 7. It is already simplified. There are no like terms on the left or no like terms on the right. So we're ready to start solving. So we should go on the side with the variable. So we need to go on the side with the y. And first we take off anything added or subtracted to the y term. So we need to take off the 5. The 5 is added, so we should subtract it from both sides. Your equals should come straight down. And we're subtracting the 5 there. Clean up. It says negative 2y equals, what's your signs on the right hand side? These are like signs. Like signs add and keep the sign. Now go back on the side with the variable and you're ready to divide. You have to divide by the sign of the coefficient. So we need to divide by a negative 2 on both sides. Clean up. We're left with a positive 1y, or y equals. What's your signs on this side? You have 2 negatives with division, gives you a positive, and 2 into 12 gives us 6. So we have y equals 6. Let's look at how to check one of these equations. You're going to take the solution and plug it back into the original equation to see if you get a true or false statement. So we're going to plug the 6 into our original equation instead of the y. Now, we're checking to see if this is a true or false statement. We don't know. So we clean up on the left, so we get a negative 12 plus 5. And those are different signs. They're going to subtract sign of the larger. It says negative 7. And this side was already cleaned up. We did get a true statement, so that means we have the correct answer. 6 is the solution. If we get a false statement here, we have the wrong answer. We should rework the problem. Some of you will start to get very good with these equations, and you'll be ready to start leaving out some steps. I want to show you the minimum number of steps that you should always write. I'm not pushing anybody to this point, but I want you to write the correct notation when you are ready to leave out steps. So if I was going to solve this equation myself and I wasn't trying to teach anyone, I would basically do one thought process per line. So I would go on the side with the x and I would say, okay, my 2 needs to come off. If it's added, I'm going to subtract it. If I subtract on the left, it's going to cancel out to leave me 5x. Notice my equals would come straight down. If I subtracted a 2 on the left, I have to do the same on the right. So 17 minus 2 would be 15. Now go back on the left and you're ready to divide by 5. If I divide by 5 here, it will cancel to leave me just x. And I also have to divide by 5 on the other side. 5 into 15 will go 3 times. So you should have at least this many steps. Here's an example that requires some simplifying first. So we will simplify on the left. We need to distribute the 2 to get our parentheses off. So 2 times x will give us 2x. 2 times 5 will give us 10. Parentheses comes off, equals comes straight down. Now we'll simplify on the right. So negative 1 and a negative 7, like signs, add and keep the sign. And now we have a two-step equation to solve. So we're going to go on this side with the x, and first we'll take off the 10. It's added, so we're going to subtract it from both sides. Clean up. Two x equals, you have like signs on the right hand side, add and keep the sign. And then back on the left, we're going to divide out the 2. So we get x equals a negative 9. I want to look at a problem that seems simple, but sometimes gives students difficulty. And I think because it looks backwards. We would want to solve for the y, so we go on that side, and that means we need to take off the 7. The sign of the 7 is in front of it, so this is a positive 7. And to take it off, we're going to need to subtract it from both sides. Clean up. Don't lose the sign of the y. Notice it needs to come straight down. Now we have negative y equals 2. Remember, you're not allowed to leave an answer like that. You need to divide out the coefficient of the y. So we need to divide on both sides by a negative 1. And that gives us y equals negative 2. Let's go a step higher and solve a two-step formula. In a formula, they have to tell you which variable you're going to solve for. And so they ask us to solve for t. That means we want to isolate the t. We will start on that side. So we find the t. Notice the g is right beside the t, so it's multiplied. So we'll leave that till last. The k is added to the t term, so we will take it off first. If it's added, to take it off, we will subtract. So we want to subtract a k from both sides. You should write it after the original piece. I've seen students that write it in front and they sometimes make a sign error. Right, so if I subtracted a k on the left, I have to also subtract it on the right. Clean up. There's nothing you can do on the left. The v minus k, they're not like terms. And on the right are k canceled. Right, go back on the side of the variable that you want. We want the t, so we're working on this side. To get it by itself, we need to get rid of the g. The g is multiplied, so to take it off, we should divide. Do the same thing on the other side. Clean up. That isolates our t. And there's nothing we can do on the left. These are not like terms. But when we have isolated the t, we have reached our goal. We're going to look at equations that contain fractions. First of all, make sure that you have an equation. It needs to have an equal symbol. Second, we're going to find the least common denominator, which we'll call the LCD. Third, we're going to multiply every term on both sides by the LCD. Fourth, we're going to simplify. In this step, all our denominators should cancel. If they don't, we did something wrong. And then fifth, we will solve. Here is an equation that has fractions. We're going to first find the common denominator. If we check, all of these denominators will divide evenly into 12. So we can use 12 for the common denominator. We're going to multiply every term on both sides by a 12. Notice we're not getting it underneath like an add or subtract problem. We're multiplying by it on the top. Then we're going to simplify each part. This is really a 12 over 1, and our 3 will cancel. 3 will go into 3 one time, and 3 will go into 12 4 times. Now we have 4 times 2 is 8 over 1. We don't need a 1 in the denominator. Then we'll simplify the next step, and that's also 12 over 1. 4 will go into 4 one time, and into 12 it will go 3 times. 3 times 1 is 3. And this one, our 12s will cancel. Then we will solve. Our x is already isolated, so we just need to simplify on the left-hand side. 8 minus 3 gives us 5 equals x. Here's another equation that has at least one fraction. We would like to clear the fractions. So first we find the common denominator. For this problem, it will be 8. So we will multiply all the way across by the 8. And you also have to do on this side, even though it's not a half fraction, it has to be every term for it to be okay. Then we'll simplify each step. Remember, this was an 8 over 1, and your 8s will divide out to leave us just y. For this next group, 4 will go into 4 once and into 8 2 times. 2 times 3 is 6. And here 8 times 2 is 16. Now we'll solve. We'll go on the side with the y, and we want to take off the 6. It's added, so we need to take it away. From both sides. And y is isolated. Here's another example of an equation that has fractions. Our first job is to find the common denominator for 5 and 3, which would be 15. We're going to multiply every term on both sides by a 15. Then we're going to clean up. 5 will go into 5 one time, and 5 into 15 will go 3 times, which will give us 3 times x is 3x. Then we'll do the next group. There's no denominators there, so we'll just multiply. 15 times 2 is 30. The third group, we can simplify with a 3. 3 will go into 3 one time, and into 15 it will go 5 times. And 5 times the x is 5x. And the last group, no denominator, so we'll just multiply. 15 times 4 is 60. Now we're going to solve. We have an x term on both sides, so we should get rid of one of the x terms. We could either get rid of the 3x or the 5x. I'm going to choose to get rid of the 5x. So I will need to subtract 5x from both sides. So I'm subtracting the 5x from both sides. This one will cancel. That was our plan. And these will combine. That will give us a negative 2x minus 30 equals negative 60. Now we have a standard two-step equation. work on the side with the x, and take off anything added or subtracted. So we're going to take off the negative 30. So we will add 30 on both sides to make this one cancel. And on the left, our minus 30 cancels to leave us negative 2x. On the right hand side, watch your signs. You have different signs, so subtract sign of the larger. And now go back on the side with x, and we're going to divide out our negative 2. So leave us x equals a positive 15. Here's another equation with fractions. So we're going to find the common denominator. This time we're going to have to go higher than 10. So how about 20? So we'll multiply every term on both sides by a 20. And then we'll clean up. The first one, 4 will go into 4 one time, and into 20 it will go 5 times. So we have 5 times 5 is 25y. Then our equals. In the next part, 2 will go into 2 one time, and into 20 it will go 10. 10 times 1 is 10. And the third part, 10 will go into 10 one time, and into 20 it will go 2 times. 2 times 7 is 14. Next, we will need to clean up on the right hand side. 10 minus 14 will give us a negative 4. And then to solve, we're going to have to divide out the 25. This time we are going to get a fraction for an answer. It's okay to get a fraction for an answer. We just didn't want to keep fractions while we were working. Equations with variables on both sides. When solving equations, we isolate the variable on one side of the equal sign. If we have a variable on both sides of the equal sign, we should get rid of one of them first. Make it cancel just like you would any other term that is added or subtracted. If it is added, you would subtract. If it's subtracted, you would add. Once we get rid of one of the variable terms, we will have a set order, starting on the side with the variable. Here's an equation with a variable on both sides. It has 6x on the left and 3x on the right. We need to get rid of one of those terms. It does not matter which one you choose to get rid of. I'm going to choose to get rid of the 3x, so I want to make it cancel. It's a positive 3x, so I need to subtract it from both sides. I usually write it after the term it's going to combine with. Cancels out on this side. On the left hand side, 6x minus 3x gives us 3x. Now we have a standard two-step equation. We will go on the side with the variable, and you take off anything that's added or subtracted. So we're going to take off the 8. It's subtracted, so we need to add to make it cancel. Then we'll clean up. This one cancels out. On the left, we have 3x equals, on the right, 15. And now back on the side with your variable, you're going to divide out your coefficient. So we're going to divide on both sides by 3. and we clean up, gives us x equals 5. Here's another example of an equation with variables on both sides. We have a 5x on the left and a 2x on the right. First, we should get rid of one of those variable terms. I'm going to choose to get rid of the 2x. It's a positive 2x, so to get rid of it, I will need to subtract it from both sides. We'll cancel on the right-hand side, and on the left-hand side, 5x minus 2x gives us 3x. And now we have a standard two-step equation. Go on this side with the variable and take off anything added or subtracted. So we're going to take off the minus 3. So we will add a 3 to both sides. Then we'll clean up. Watch your signs on this side. We have different signs. Subtract, sign of the larger. And then go back on this side with the variable. We need to divide out that coefficient, which is 3 on both sides. And that will give us x equals negative 5. Here's an equation with a variable on both sides, and it also requires some simplifying. So first we'll work on the left-hand side and distribute the 4. That will give us 12x plus 16. Parentheses comes off. And then we have some like terms on that side. So the 16 and the minus 20 can go together. They are different signs. Subtract, sign of the larger. Then we'll work on the right-hand side, and we have some like terms there. The x terms are alike. They are also like signs. So we're going to add and keep the sign. And I like my variable first, so I'm going to write it first. Plus 3. I'll just bring it down. Now we're ready to solve, and we have an equation with a variable on both sides. We should get rid of one of those. I'm going to choose to get rid of the 5x. I can kind of see 12 minus 5 will give me 7. When you're ready to do that, it's fine to do that step in your head. We'll go ahead and write it this time. So I'm going to subtract a 5x from both sides. This one cancels, and on the left-hand side these go together to give us 7x. Now we have a standard two-step equation. On the left-hand side, you're going to get rid of your 4. It's subtracted, so you will add. Do the same on the right-hand side. Clean up. And then go back on the side with your variable, and you're going to divide out your coefficient. So we're going to divide on both sides by 7, which will give us x equals 1. We'll look at one more example of an equation with a variable on both sides. And I'm going to do this one for you both ways. First, I'm going to do it and get rid of the 2x. So if we get rid of the 2x, we're going to subtract it. But notice on the right-hand side, it's going to wipe your side out. When that happens, you have to write a 0 because you have to have two sides. So we'll combine on the left. 3x minus 2x gives us just 1x, or x, plus 5 equals comes straight down. You have to put a 0 here. A lot of times I'll see students just move this equals over and make a side. That's an illegal step. You can't do that. But you can always fill in 0 if a side cancels. Now we're ready to solve, and it only has one piece to get rid of. So we need to get rid of the 5. It's added, so we will subtract. Clean up, and we get x equals negative 5. I want to look at the same problem with you another way. We could have chosen to get rid of the 3x. If we get rid of the 3x, we're going to subtract it. It's a positive 3x. And we have to do that to both sides. Cancels on the left. And this time our side did not wipe out. We have a negative 1x there. Remember, you're not allowed to leave a negative x, so we're going to have to divide out that negative 1. That's our coefficient. To get negative 5 equals x. So you do get the same answer. Doesn't matter which one you get rid of. Special equations. What does it mean to solve an equation? It means to find a solution, the value or values that make it a true statement. Let's try to solve this equation. So first we will simplify on the left by distributing the negative 3. And this will give us negative 3 and plus 9x. Parentheses will come off. There's no simplifying to do on the right-hand side. Our next step would be to get rid of a variable because we have a variable term on both sides. So we're going to have to subtract 9x. And we'll do this on both sides. But the variable term disappears. It cancels from both sides. This is a special equation where your variable has canceled out. What we care about at the end is whether we have a true statement or a false statement. If we have a true statement, like we do here, this one is true, our answer to it is all real numbers. Everything would make this equation true. This one is called the identity. So our solution is all real numbers. You could pick any number at all and plug it through the original and it would work. These were actually just alike. If you looked closely, they're turned around and it was disguised in the first part. Let's try to solve this next equation. So first we'll simplify. On the left-hand side we can distribute the 4. This will give us 8 plus 4x plus 1. And we can combine the 8 plus 1. So we have 4x plus 9. Then we will distribute on the right-hand side the negative 3 to the parentheses. So bring down our 7x minus 3x. Careful here, plus 6. And the x terms can go together. 7x minus 3x is 4x. Bring down your plus 6. Now we have a variable term on both sides. We need to get rid of it. So we're going to have to subtract a 4x. We'll do the same on both sides. but we'll realize that our variable term canceled. We don't have a variable to solve for. This time, we ended up with a false statement. So we want to answer that there is no solution. This one will never be true. When you're more experienced, you'll see it from this third line. The 4x is the same on both sides. The 9 and 6 are never going to be the same. This one is called a contradiction. And your answer to it will be no solution.